Hi there, and welcome to Chapter 6. Here's another lesson that I don't normally teach as an embedded lesson. I just give as practice work during class, which is why you aren't going to find these notes in your packet. But if you want to either print or take notes along with it, you absolutely can. Also, this is something that several of you are going to feel confident jumping straight into without maybe finishing the whole notes. And while I don't encourage that normally, this is generally a topic that students have already mastered and just need a little bit of practice in the textbook to fully remember from previous years. So if you want to take notes, let's get started. So we're going to talk about the area and perimeter of quadrilaterals, and we're going to focus specifically on parallelograms. Now, that means that we're also going to talk about rectangles because a rectangle is also a parallelogram. It just happens to be a parallelogram with right angles versus ones with acute and obtuse, like we see here. And of course, a square is a type of rectangle, which is, again, a type of parallelogram. They're all in the same big category, where a square is a rectangle where all the sides are congruent. So, first of all, if you don't have this formula internally memorized already, that's just fine. The area of a parallelogram is the base times the height. Now, sometimes the base is really easy to tell because it's nice and on the bottom. We sometimes call it the length, and the height is up and down. Now, if sometimes though, we've all seen this where our textbook will just draw it in kind of like a weird way where it's at an angle or it's twisted around. So just always remember that the height and the base are perpendicular. So if I draw it at a weird angle like this is still a parallelogram. And if we have a segment here and it says it's a right angle, well, that just means that this green is the height and the place where it meets is the base, even though it's kind of flipped around and weird. So something to keep in mind. In number 1, it says find the areas of the figures below. So these are both parallelograms. One's a rectangle, one isn't. And we want to draw in our base and our height so we can use that formula. In number 1, we've got our base here, and this is 1, 2, 3, 4 squares. Make sure that you're counting the squares in the cases of graphing, not the lines. And our height would be our internal perpendicular, because vertical and horizontal lines are perpendicular, which is 3 spaces. So for A, the area is equal to base 4 times 3, which is 12. And now when it comes to writing your answers, writing it as 12 is just fine because there is no unit given. You could also write this as 12, and since it's area, that would be units. Squared would also be just fine. Now I'm saying this because 12 squared is not, because the unit are square and there are 12 of them. 12 squared is 144, which is definitely not the area of this shape. In the case here, we might call this the length, or we might call this the base. That's just fine. Base here is 5 spaces, and again, the height is 3. So for B, we could say that the area is 3 times 5. So the area is 15. Again, I would accept area is 15. There's no unit given in here. So you could also write this as 15 units squared, but either way is fine. Now, however, if we look at number 2 is find the area and perimeter here. You'll notice that they do have units here. They are centimeters. So we need to make sure that for our area, our unit would be centimeters squared. And for our perimeter, remember the perimeter is the distance around the outside of a figure. So in this case here, all the way around it's called compound figure when it's made up of multiple smaller shapes, would be measured in centimeters. Now, which one you want to do first is up to you. I'm just going to do them in the order that they are written, which means that I am going to start with the perimeter. Now, the perimeter going around the outside, we're given a lot. So if I go around the outside here, I've got 2, 2 centimeters plus 2 plus 2 plus 3. And then this is the first side that's not given, but we can see these two opposite are the same. So plus 2 plus 2 and down. Again, it's not labeled, but we can see that these two opposites are the same. And 7 across the bottom. And now you'll notice that the entire shape I've drawn in as I've added. And so this is really important because you don't just want to add the ones that are numbered, because then you would have missed these two sides. Writing it all out like this is a little cumbersome, but then the nice thing here is you'll notice that you have 6 2's and then plus 3 plus 7, which makes it a lot easier. So this becomes 12 plus 10. So the perimeter is 22, and since there is a unit in the original problem, we say centimeters. For the area, there's a lot of different methods to use for area. In this case, what I would do is divide this into 2 shapes and think of them separately. So this shape down here is nice, it's easy. Here's we've got our base, here's the height. So 7 times 2 would be the area of this one here. The upper one, we don't know what this length is, but we can see, oh, these two are perpendicular, so we can use those as our base and height of 3 times 2. So again, you're not always looking at the bottom for the base, you're just looking for a perpendicular set of sides inside of a parallelogram. So here I would say 7 times 2 for the bottom plus 3 times 2 for the upper section. Following our order of operations, that's 14 plus 6, which is 20, and then the unit would be centimeters squared. Please let me know if you have questions about anything. Nominate the problems you're stuck on in the form, and I hope to talk to you all on Zoom or by email or whatever method is easiest for you.